Hello folks, welcome to CodeCrucks. In this video, we will discuss one more example on minimization of DFA. Assume that this is the DFA that we wish to minimize. It is having 8 states. The transition table for this DFA is having 8 rows because there are 8 states. If we look at this DFA carefully, then Q4, Q5, Q6 and Q7 are non-reachable states. If we start from initial state Q0, there is no way to reach to any of these 4 states. So we can cut them down and our final transition table would look like this. So we will start with that. To find the equivalent minimized DFA, we have to first construct P0 partition or the 0 equivalent set of states. For that, we have to divide the states into final and non-final states. Q0, Q1 and Q2 are non-final states, whereas Q3 is final state. We will not consider Q4, Q5, Q6, Q7 for the computation because they are anyway not reachable from Q0. So we don't have to include it. Now Q0, Q1 and Q2 may or may not be equivalent. We have to make a test on that. So we will run that equivalency algorithm and we will see that either of the states are distinguishable or not. If any of the state is distinguishable, then we have to split this red group into multiple parts and we will continue with that process. To check the distinguishability, we will do one equivalent test or we will create the P1 partition. So we have to read all input alphabets A and B from all 3 states. So Q0A will lead to Q1, that is the red set. Q0B also leading us to the red set. Next, if we read A from Q1, we are moving to Q0, that is the red set, and on reading B from Q1 again we are moving to the same group. So Q0 and Q1 are definitely not distinguishable as of now. If we read A and B from state Q2, then we are moving to blue set or blue group and red group. That means Q2 is distinguishable from Q0 and Q1, but Q0 and Q1 themselves are not distinguishable. So we will split that red group into 2 subgroups. One contains Q0, Q1 and other contains Q2. So this is our partition P1. We have to make sure whether Q0 and Q1 are equivalent or not. To do so, we have to compute now P2 partition or we have to check for the 2 equivalent. So we have to read input alphabet A and B from Q0 gives us output Q1 and Q0. Both belongs to red set. If we read A and B from state Q1, then on A it goes to red set and on B it goes to green set. That says Q0 and Q1 are not same. They are distinguishable because their transitions fall into different groups. So they are distinguishable and hence we have to split that Q0 Q1 group, red group, into 2 subgroups. In one group we will put Q0, in another group we will put Q1. This is P2. All 4 set of states are having only one state. That means no further reduction is possible. If we have multiple states, they may be identical and hence our algorithm will stop here. And when we draw the final DFA, minimized DFA, it looks like this. So reduction of this DFA is not possible. Only non-reachable states we have removed. In previous few examples, we have seen that we could successfully remove or eliminate few states. But here we can only remove the non-reachable state and whatever 4 states are left, they are all distinguishable and we cannot merge any of the state. And hence the input will be the output DFA. Thank you. That's it for today folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.